right, in 4.1a, we're going to talk about simplifying radicals. So we're going to use the product property of radicals to do this. That property says that if you have the root of a times b, then that is equal to root a times root b, where a and b are greater than or equal to 0, right? Because you can't always take the roots of negative numbers. So let's look at an example. So number 1, we have the square root of 81. Now you might know off the top of your head that the square root of 81 is 9, because 9 times 9 is 81, and that's what the square root is asking for. But I'm going to show you how to break it down and how you would need to do it if you didn't know the answer. So we're going to make a factor tree and say what multiplies to 81? Well, we know that 9 times 9 is 81. And after you've broken something down, we're actually going to cross that off so we don't get confused and think we have to do it again. So we're crossing off 81, and now we have 9 and 9. Well, 9 can break down to 3 times 3. And same with this 9. 3 can't break down any more besides 1 times 3. But if you can't break down to anything besides 1 times itself, then we can just stop there. So what this means is that 81 is equal to 3 times 3 times 3 times 3, right? We have these 4 3's down here. So we could say that the square root of 81 is the square root of 3 times 3 times 3 times 3. Now, if we look at this, 2 3's, right? 3 times 3 is really 3 squared. So really we're doing 3 squared times another 3 squared. And we know that because of our product property, that that's the same as the square root of 3 squared times the square root of 3 squared. And what happens is that squared and square root actually cancel each other out. And we're just left with 3. And again over here, we're left with 3. And 3 times 3 is 9. Now, there's a way that you can get this answer without having to write this whole part out. After you make the factor tree, we know we're looking for groups of 2, right? Because it's the squared that gets canceled out. So we have a group of 2 3's here and 2 3's here. And so each of those groups are going to turn into 1 3. And then we multiply them and get 9 as our answer. So let's do another example. Let's look at number 2. We have the square root of 27. So if we break that down, what multiplies to 27? Well, we could do 3 times 9. And 3 won't break down anymore, but 9, we can do 3 times 3. And so now we're done. We have 3 3's. So again, we're going to look for a group of 2 3's. And then we have 1 3 left over. So what is going to happen is we're going to pull this 3 outside of the root, and that leftover root 3 is going to stay under. So if we think of it, we have the square root of 3 times 3 times 3. 2 of those will make a 3 squared. So that squared will cancel out, and we'll have 3. But then the last 3 is going to stay under the root because it won't cancel out. So our answer for number 2 is 3 root 3. Okay, let's look at number 3. We have the square root of 48. So again, what multiplies to 48? Well, we could do 6 times 8. And it doesn't necessarily matter which factors you choose if there's multiple options. You could also pick 2 times 24. And once you break them all the way down, you'll get to the same thing. So it doesn't necessarily matter that you pick specific factors, just correct ones. So 6 we could break down to 2 times 3, right? And since we've broken that down, we're just going to cross it off. 2 and 3 won't break down anymore. That's as far as those guys can go. But what about 8? Well, that's 2 times 4. And then 4 is 2 times 2. So now we have 2 2, 2, 2. We have 4 2's and a 3. So we're looking for groups of 2, right? Because we're doing a square root. So we have one group of 2 here. There's our second group of 2's. And this 3 doesn't have a group. So that means it's going to stay under the radical. And then for each of these groups, we can pull out 1, 2. Okay, and then 2 times 2 is 4. So we're going to get 4 root 3. All right, let's do another one. For number 4, we have the square root of 108. So 108, what could that break down to? That could break down to 9 times 12. And 9, we could say is 3 times 3. And we'd stop there because 3 doesn't break down anymore. What about 12? Well, that's 2 times 6. Okay, and then 6 is 2 times 3. So here we have a group of 2 3's, we have a group of 2 2's, and we have 1 3 that's by itself. So we have from our group of 3's, we're going to pull out 1 3. From our 2's, we'll pull out 1 2. And then our 3 will stay under the root. So we have 6 root 3. All right, so go on to the next video and we're going to talk about simplifying other kinds of radicals that are not square roots.